All right, who remembers E? So fun. It's the base of ln. So hopefully this feels like it makes sense because we just finished our section on logarithmic differentiation and integration. So now we're going for base E, okay? Again, if you have ln of x equals y, the exponential form would be e to the y equals x. So that's kind of what they're doing here. I just switched around the variables a little bit. Okay, so the nice thing is that ln of x and e to the x have an inverse relationship. So if you ever take the ln of e to the x, it becomes x. And if you raise e to the ln of x, it becomes x. So those little operations we're going to just go through quickly to remind your memory a little bit. This first set of notes is just going to be the first few slides, so we're going to kind of break it up into sections like usual. Just a reminder of some of those properties of exponential functions. So if I have like 2 to the third times 2 to the sixth, you add the exponents, right? Same thing with e. If you have e to something times e to something else, you can add. If you divide, you subtract. All right, so we are going to use some of those logarithmic equation properties to help us solve some stuff. So this is more of a review of pre-calc, algebra 2, all that. When I have something like this, I can put it into logarithmic form. So I'm going to remind you of that right now. If I have e to the x equals y, that's the same thing as putting it into log form and saying ln base e of y equals x. So easiest thing to remember, your base is here, these two values on top switch. Or if you want to go from exponential to, or logarithmic to exponential, I use the seashell method, but if you've never learned that, take your base, raise it to this, set it equal to that. And to me, it kind of looks like a seashell, so hence why I call it the seashell method. So if you're trying to go from exponential to logarithmic form, it gets rid of that base. So the nice thing is if I put it in logarithmic form, I just do ln because it has a base of e. So I write my base, swap the x plus 2 and the 8. So this becomes 8. That becomes x plus 2. And then you just put it in your graphing calculator. The nice thing is ln base e of 8 is just ln of 8 in your calc. The ln button is right below the log button. So you can literally just do ln of 8, subtract 2 from both sides, and that gives you about 0.08. So that would be your answer. The next one is going backwards, so putting it into exponential form to get rid of the ln. So my base here is e, so I can put it in exponential form. Seashell. You don't have to make that sound, but if you do, I can't hear you, but hopefully you're doing it. Okay, so e to the 11th equals 5x minus 4. Put it in exponential form so the ln goes away. Now I can just put e to the 11th in my calculator, add 4 to both sides. That's a 4, not a 1. And then you can divide by 5. Right, so get x by itself, put it all in your calc, and you end up with approximately 11975.63. Ta-da, magic. Exponential magic. Sorry, I get a little loopy around this time of day. I'm doing this on Friday at like 3 o'clock, so my brain is not working. Anywho, this is the rule of equalities, meaning if you have two things that have the same base, different exponents, think of like 2 to the 1 equals 2 to the x. X has to equal 1, right? So you can always, as long as they have the same base, set the exponents equal, and then they just drop. Sweet. And then x is 8. Also, being pregnant is fun because you're out of breath all the time. Whew, okay. Same thing here, you're taking the ln of both sides, so it actually cancels as long as it's condensed first. So 5x minus 4 equals 11. Solve for both sides. That's right. You end up with 3. Good job. All right, I'm going to have you try the next question. Think about some of those properties. See if you can figure it out. If you can't, I'll help you out in a second. The other few we're going to go through a little bit together just because I want to make sure you're good to go. We'll do some of them and then you can see what you can get. All right, figured this one out. I'm proud and excited for you. What you might notice is that this has the same base as this. When that happens, if they both have a base of e, they cancel. So you're just left with 2x equals 12, which means x equals 6. If you forgot about that property, it's kind of like saying 2 to the log base 2 of x equals 6. If you think about putting those into exponential form, the log actually would disappear, and then you have something like 2 to the x equals 2 to the 6th. So again, it goes back to that property from above there. So x equals 6. Same thing here. If you put it in exponential form, it also works, but the faster route is just cancel the same base, and you're good to go. This one you could do in two different ways. You could either move the 2 down first. That's one of those nice properties of logs as well. And just say 2 ln of x equals 10. So ln of x equals 5. And then put it into exponential form. So that would end up being e to the 5th, because our base, again, is e, equals x, which is about 148.4 if you put it in your calc. If you forget where the E button is, it's directly above the ln button, but you have to hit second and then ln first. Okay, the next few are exactly like these. I'll have you try them. Just a heads up, the other thing that you could do is immediately put this in exponential form. Then you have like x squared equals e to the 10th, and you could square root both sides. Just be careful, because then that brings you to that again, not something different. But anyway, I'm going to have you try the next quattro, next 4, cat, if you speak French. And then when you're done, I will have the work and the answers for you. All right, guys, hopefully you got 3.03 for 4, or for 2, sorry. Then 3 was 1.54. 5 was 0.68, and then 6 was 405.43. So feel free to check out my work. If you have questions, join my office hours. All right, next up, we got some of the derivative rules. So what I want to show you real quick is actually a little diagram of, or the graph of e to the x. So if I were to graph e to the x, it looks like this. If I were then to take the derivative of e to the x, that is the slope at every point, right? So the slope here is pretty close to 0, pretty close to 0. It's getting bigger and bigger and bigger, and then it gets really, really big quickly. Now, if I were to graph that, I just did in red. So what's weird is that the derivative of e to the x, I wish I could slide this away, but it is, ta-da, very odd, e to the x, okay? If you have a different value in the exponent other than x, same idea as what we're used to doing. It's e to the u, because their exponent is u, times the derivative of u. So a little chain rule action that we're used to doing there. Okay, so for the first example, 5 times the derivative of e to the x, well, the derivative of e to the x is e to the x, so this is just 5 e to the x. Crazy. Okay, think about this as u. So you're going to have to do e to the x squared plus 3x, like we're used to doing. Just remember you have to multiply by the derivative of that. So times 2x plus 3. And you can leave it looking gross if you want. That's really just your answer. Or you could put the 2x plus 3 in front if that makes you more comfortable. For But the next one, see if you can try it, and then if you get it, awesome. If you don't, I'll work you through it. But if you want to try it out, feel free to pause and then you can try it. But this one would be e to the negative 4 over x, but then times the derivative of, what's that? Remember, this is the same thing as negative 4x to the negative 1. So if you take the derivative of that, that becomes 4x to the negative 2. So a better way to write this would be e to the negative 4 over x times 4 over x squared. The more beautiful version, again, is to put the 4 in front, so it'd be 4e to the negative 4 over x all over x squared. You can't do anything with the x squared and the exponent, unfortunately, because they're to different bases, but this is fine as an answer as well. All right, try these 3 out for me. There's a little bit more going on here because there's a little chain rule. Sorry, that was my husband dropping something out of the fridge. So these are a little bit more involved because they include taking the derivative of ln, which we just learned, so hopefully you'll remember. And the first one is chain. So try them. I'll have the workout for you when you're all done. All right, guys, hopefully you got that answer or those answers. For the first one, it ends up being kind of a long chain rule process because you have to move the 5 down, rewrite the inside, lower the exponent, multiply by the derivative of the inside. The thing to be careful of is we don't know the derivative of t, and they're asking you to take the derivative of x. So kind of like when we take the derivative of y, you have to do dy dx. This is dt dx. So throw that in there if you didn't include that. The other two are in terms of x, so you're good to go. But what's cool is the second one just turns out to be 3. You can actually do a shortcut with this one because the ln of e is 1. So you're literally just taking the derivative of 3x. Surprising. This one you can't do that because there's a plus sign in between, but it simplifies pretty nicely, which is good. All right, last part for today. We are going to do the derivative of a trig function. The relative extrema we're going to do next class, so don't worry about that yet. But a thing to be careful of here is that you're doing the tan of x times this whole quantity. So that means that you're going to have to do the product rule, okay? So the derivative, so first times the derivative of the second. I would use parentheses because you have to do e to the negative t times negative 1 dt dx. Again, be careful, that's a t, plus the derivative of e to the x is just e to the x. So first times the derivative of the second, plus the second times the derivative of the first. Ooh, who can remember the derivative of tangent? Secant squared of x. And I personally would just leave this alone. That's garbage. All right, second one, quotient rule. Low d high minus high d low over low low. So low d high minus high d low all over low squared. Ta-da! And you can't combine like terms, really. And you can't factor out an x squared plus 3. So what I would do is clean it up a little bit. So let's just make it 5e to the 5x times x squared plus 3 minus 2x times e to the 5x all over x squared plus 3 squared. So technically you could factor out an e to the 5x, but unfortunately you can't combine like terms if you do that, so personally I would leave it. All right, that's all she wrote for today. Literally, that's me. That's all I wrote. The rest, or the next section, will come at you tomorrow, and then we'll finish the last section the day after. Enjoy.